Good afternoon, evening, and good morning to everybody here. Welcome to another one of our Maxon demystifying presentations. I hope it's good to see you all. Question, of course, that we need to ask: can you hear and see us? Yes, we have some greetings. Just waiting for some responses. Yes, is the answer. Fantastic, loud and clear, phenomenal. Right, okay, the answer to your next question is yes, this webinar is being recorded, and you will be able to find your webinar recording through the link of the registration, and you'll get an email after the end of this webinar that will give you the link to access this as necessary. Of course, if you want to see any of our previous things, you can register, or well, not register, you can click on the link, but equally you can find our YouTube where it says our Maxon volume program training, where you can see even our last 2 weeks of webinars are already there. So I shall thank Simon for
not seeing your screen, Matt, at the moment.
Oh, you're not seeing my screen, right? That's going to be really daft, isn't it? So
right, I know you want it to be all about us, but sometimes it's about the software too.
You might need to see my screen.
Our faces are not enough.
In fact, we should do it actually without screen, just miming it.
That's it. We are now going to do Cinema 4D through the medium of contemporary dance with no webcams. So this should be exceptionally interesting. So hopefully you can now see my screen. There we go.
Yes.
You need to access the previous webinars, then you can see Maxon volume program training here on our YouTube channel, and you can see everything that we have done over the last however many months of these nice demystifying tutorials. Of course, you can see what's coming up next, and we have for October demystifying post-productions, stylistic treatments and effects for editors with our Red Giant people, Jason and Nick. So that would be really good. I'm sure Simon will be in there as well. And of course, for any other tutorials that you are interested in looking at, then you can go to our Cineversity, which comes with any subscription. Okay. Right,
fantastic.
So today,
almost like you've done that before, Matt.
It is like I've done that before, isn't it? I'm going to get used to saying this like a spiel, and eventually I'll say it really fast like an advert. Of course, looking at our last one today, September the 28th, fracturing in motion graphics, thinking outside of the box. So we are going to be taking a look today at the Voronoi fracture, and what I'm going to do, I am going to stop sharing my webcam, and we will have a look at Cinema 4D and Voronoi fractures in R23. Don't forget, guys, we are here to answer any of your questions, so feel free to just pipe up and ask us some questions in the little chat box, and my colleagues will be busy answering them. If there is something that they feel that they could ask and other people want to know, then they will simply interrupt me and I will do what I can. Right, okay, so let's have a look. The Voronoi fracture then exists, of course, as part of our MoGraph toolset down here. Now, the Voronoi fracture has a very specific thing that it does. It fractures under the mathematical principle of a Voronoi. As you can see for the moment, it's a generator, so it needs something to go inside of it. It will not do anything at all. So let's create something and put it inside. And you can see we get these lovely colors that fracture our object that you put inside, and you can put multiple objects inside, but I'm going to keep this simple and let all of the exciting things occur with Jonas and Elly while I just explain what's going on. So to explain what's going on, I'm going to use a little feature in Cinema 4D called a doodle, and the doodle paint will just allow me to just quickly explain how the Voronoi fracture works. What it does, it creates lots of points all over an object, and then the Voronoi halves the distance between the points. So what it'll do, it'll draw a line between that point and create a line, and then between this point and this point it will create another line, and between that point and that point it will create a line. So this kind of Voronoi mathematical lining is what will create your segments between various different things on your object. So that the points will all exist. If I just get rid of my doodle now, and I have a look at my object itself, if I go to my fracture, there are lots of settings. I'm going to go through a few of these in a minute. But if I just go to my sources and click on my point generator, you can see we now have these little green points, and they are those points I was just talking about. And the fracturing happens in between. So we've got 2 points there and a line that goes straight down the middle. And of course, it happens in 3D, so it's a lot more complicated than the 2D sort of example that I gave, but nonetheless, that is how the Voronoi fracture works. So let's have a look at some of these settings that we have. Obviously, we've got our basics, which are normal, and the coordinates are standard, but let's have a look at our object one. We've got a colorize fragments, and that just allows you to see those fragments that are being created. It's a really useful way of just being able to discern exactly what is being created when you edit some other settings. Offset fragments is quite a nice little one because it will literally offset the fragments so we can start to see how they are being fragmented. Okay, and you can invert that function, which sometimes gives you some nice things to look at, and that will give you the gaps as opposed to giving you the actual fragments themselves. Just going to undo that as well. You can choose hull only, which means that it will just do a single skin of the objects rather than treating them like they are a sort of a solid sphere that has been smashed into bits. You can see that it is made up of lots of little surfaces instead, which you can actually give a thickness to if you want, so that you can actually make it look like it's some form of shell with a thickness as opposed to just a complete single skin object. So that's just very quickly the object tab, which I'm just going to undo and switch that back off to 0 so that I've got my solid objects. Sources I will come back to in a second because that will lead me on to other things. One of the most other interesting ones to look at is the detailing tab. Now, what the detailing tab is, as you can tell when I tick the box, is it allows you to detail the surfaces, which you can't currently see until I offset the fragments again. So let's go back onto there and offset. Now you will notice that the surface of my fragments is not quite as flat and as mathematical as it had originally been created. And I can have a look at that detailing, and I can change the noise strength, and I can make it stronger, I can make it weaker. You can see the difference between disabling that, which makes don't copy and paste, which makes very, very flat segments and doesn't look particularly like something has been smashed or broken, as opposed to this, which gives you a little bit more realism in the surface. Now, you may note, of course, that the actual Voronoi lines that are created are still very mathematical. They're still very straight. So you can untick use original edges and keep original surface as well, and you will see that you get a much more interesting look. And if I just shrink that back down, you can see that this now feels a lot more like a shattered meteor or meatball. Not that you'd want to shatter a meatball, but you can. And you can use this offset and that detailing to do it. There are quite a few other settings here. In fact, to be honest, we could spend an entire hour going through the settings of the Voronoi fracture without actually showing you anything cool, which I'm not going to do. So I'm just going to give a quick overview. You can give geometry glue, which means that if you wanted to, you can actually glue various parts of this object together to stop, say, these two segments from smashing apart. And of course, being a MoGraph object, you can use effectors, which I will come to in a minute. So there are a couple of different ways of using the Voronoi fracture. I'm just going to simplify this for the moment. We can, of course, with effectors, use obviously the effectors that we have in our MoGraph toolset, such as random. So let's use the random, and we can happily sort of explode our segments. And of course, our parameter is set quite low. So let's just explode these out an awful lot. And we have more segments floating around. Okay, now if we wanted to increase the number of segments, what we can do, we have a look under the Voronoi, under our sources tab. It's going to turn off the random effector for the moment, because we shall come back to that. So the point amount is the number of points here at the bottom. This lets you know how many points are being created. This is our point generator. It is generating these points all over the inside of my object, 20 of them, and a random seed generation to just denote where these points are randomly created. If you wanted more segments, you would need to increase the number of points that are there to increase the segments that are created around it. So if I choose 40, there are now 40 points. That doesn't necessarily mean there are 40 segments, but that there are 40 points that are creating this distribution of segments. As you can see, we have a distribution type. Now, if I change that from uniform to normal, then it is more on the internals of your object. You can change that to inverse normal, and it is more on the externals of your object. You can also go to exponential, and this one's quite nice because you can actually sort of move points and denote where the points are going to be created. As you can see at the moment, I've got x-axis affection, and it will be more towards the plus axis. You can choose minus and it will be more towards the minus section, or you can choose off and it will basically be like a normal distribution. But you can put pluses in each of the directions, and you can basically scrunch all of the segments of this up one particular area. And this will make a lot more sense and why you'd want to do this when I get to one of the other ways that you can use the Voronoi fracture outside of the random effector. So for the moment, I'm just going to keep that on uniform and have relatively uniform distribution of my points. And if I turn on my random effector, I now have a lot more points spreading around, a nice sort of meteor shower of stuff. Okay, and of course, what we've looked at over the last few weeks, in order to choose where this is created, you can choose a fall off, and I can create a linear field. And now if I move my linear field from one side to another, I can break apart my meteor meatball and then bring it all back together with my linear fields. And of course, you can do that with any particular object if you want to. So I can take my sphere out and let's put in some motext. So let's put some motext in there instead, turn off my sphere. And now if I move my linear field, I can bring together my text, which is very crumpled indeed. Okay, one thing that's useful to know when doing this with text is, whilst I have 40 points, it has taken those points and put them across the entire of my text rather than one per letter. If you want to do that to save creating lots more points unnecessarily, what you can do, you can select your Voronoi, select your point generator distribution, and then it says create points per object. And if I just put a tick in the box, I will now have 40 points per letter, as opposed to 40 points across the entire thing. So it just means that you get a nice, better spread of destruction, particles, segments, whatever, depending on what it is that you are trying to create. Okay, so that's one way that you can use your Voronoi fracture. Another way is to use dynamics. So let's just create a new object and let's do several things. So I'm going to create a sphere and I'm going to create a floor. This will allow me to have my sphere impact onto the floor. Now let's create a Voronoi fracture, obviously, otherwise this is going to not happen. So let's create a Voronoi fracture and let's put our sphere in our Voronoi. Okay, so this will use its segments to smash itself apart, and it would simply use dynamics. So what I can do with my Voronoi, I'm going to go to tags, simulation tags, and I'm going to choose rigid body, and with my floor I'm going to go tags, simulation tags, collider body. Now if I'd have had them both selected, it would have done that for me. And now let's press play. Whee, smash. Okay, so I can just simply press play and my sphere will smash itself apart on the floor into the segments that I have created. Now I can actually control these segments with more interesting information. So at the moment, under my Voronoi fracture, as I've said, my point distribution, basically what is making the segments, is being done with a Voronoi point distribution creator. If I turn that off, I now have well, just a sphere, which isn't going to break or smash or do anything because it is one solid segment. I can control, however, how to create these segments, and I can actually use other things to denote where those Voronoi points are created. And for this instance, I'm going to create a plane. Now, if I just go to my points, viewing my lines, sorry, you'll see that my plane is set by 10 by 10, and I have lots of lovely square segments in my plane. Now, with my Voronoi selected, I'm going to drag and drop my plane into my sources. And now you can see that my Voronoid sphere is made up of, well, chips. It's going to make itself up of slices. I'm just going to hide the plane, and I'm going to go back to my normal view. And now if I press play, my Voronoi smashes itself apart like blocks instead. And this is all still live and procedural. So if I have a look at my plane and I see that it's made 10 by 10, if I did 20 by 20 instead, then of course there are more segments. And you can even control where that happens by moving the plane as well. So now if I press play, actually I really like the way that that opens up kind of like a flower. That's really cool. So you can control exactly how things break apart and how things smash as well. You can, in fact, even go completely crazy and use the Voronoi and combine the two, or have various other things that will control where things are smashed and how stuff is controlled. You can add shader sources, add different distribution points, and you can use multiple different objects inside of your inside of your Voronoi fracture to smash things apart and use the Voronoi to its fullest potential. Okay, there was a very brief and rather sort of quick introduction to the Voronoi. It is obviously huge and you can do an awful lot of stuff with it. So are there any questions before I hand over to Elly?
I don't think so. Not
okay.
Relating to the Voronoi fracture. Someone did ask what was the concept of the doodle, but I think it was just so you could do an explanation, wasn't it, of the Voronoi?
That was simply so I could doodle on my screen without having to load up anything else, and maybe show another, probably less known feature of Cinema 4D.
And another one was, what did you use with the tags? So it was a rigid body, wasn't it, and a collider body?
So yeah, you have a rigid body on your object. So to say this is solid and it has dynamics on by default. And the thing that you want to be stationary, you create a collider body. So the dynamics are off, which means it stays still while other things smash into it. Okay.
Cool. Yeah, I think that might be
introduction then. So what I will do, I will now send this over to you, Elly.
Yeah, cool. Sounds good.
Examples. Cool. There you go.
Cool, thanks. So can everyone see my screen?
I can see it.
Yes, we can.
Cool. Perfect, thanks. So leading on from what Matt said, how we can use different sources to kind of generate our fractures, I like that we titled this like webinar kind of like thinking outside of the box. So it's not just about like, let's get an object and smash it into a million pieces. As fun as that is, and as much as that's what we all love to do, I thought I'd show this project here where you can sort of generate slices by using something that's like the matrix object in MoGraph, and then using a couple of effectors to create this sort of like coming apart ribbon effect. And I thought it'd be like something nice to show from like the beginning. So let me open up this and I'll kind of explain how I got to that final look, which is actually, it's quite simple, really. So if you grab yourself a sphere, I'm just going to make that a little bit bigger, and I'm going to increase my segments just to like the nice like smoother edge. And then let's get a Voronoi fracture. So if we just make our sphere child, you can see that the default source is, as Matt said, this point generator, but we don't want this. We're going to just remove that. And then, as Matt did, you can drag and drop pretty much anything in there. I'm going to grab a matrix. I'm going to set that to linear. And so if I drag and drop that into my source, you can see these three kind of like matrix objects here creating these kind of like fragments. So now if we go into our matrix, we can change some of these settings around. So if I want to move this all the way to the bottom and then change my mode to endpoint, because I want to choose where it ends on the Y, and I want that to match up with kind of at the top of my sphere. And then my count, let's do something like 70. So you can see here how it's kind of like evenly sliced my sphere. Now let's rotate my matrix a little bit just to make it look a little bit cooler. And then if we need to, it might just be a case of kind of like messing about with some of the settings just to make sure it goes all the way to the top and all the way to the bottom, which it does. Cool. Bring that a bit. There we go. Cool. So it's starting to kind of like take shape already. So if we use our little traffic light options and double click just to hide our matrix, because we don't actually need to see that, but it's still going to affect our Voronoi fracture as a source. We can come into our Voronoi fracture and go to the object tab. And this is where Matt was telling us there's all kind of like a bunch of different settings to create the different looks that you're after. So if I offset my fragments, you can see now that my sphere has been made up of all of these sort of like flat discs, and there are fragments. And then the hull only option is the one that I went for, because it sort of creates like kind of like a ribbon look. And this was the basis of my project. So this is where it starts. And then because the Voronoi fracture is one of our MoGraph generators, we can actually use some effectors on it. So with our Voronoi fracture selected, we can come up to MoGraph effector and then random, and it's going to kind of randomly affect the position. I think it's about 50 centimeters on the X, Y, and Z. So I'm going to pull that down a little bit because I don't want it to be quite as kind of dramatic as that. And then a bit of scale, 0.5. Cool. But what I want to do, I want it to affect just like the top and then just the bottom parts of my sphere. So it's almost like it's unraveling. So I want the whole middle of it not to be affected. So last week, if you guys were there, we went through fields. And if you haven't seen that, I'd recommend having a look at that. And then we can, so in this section here, we can then grab ourselves a field. So I'm going with a box field. And then I'm just going to rotate that, make it a little bit smaller, and then kind of like position it just at the top. So now my kind of like random parameters are only going to affect what's in this little box here. So we can kind of move that to the top. A lot of this is sort of like personal preference, this sort of like look. So you can place it where you want. You can choose the settings that you want. So whatever you like the look of, really, it's down to you. That's the wonder of motion graphics stuff. I'm going to add another box field, and this time I'm going to put this one kind of down the bottom, just so it affects these parts. Cool. Right, so that's already kind of getting there. Yeah. And then I'm also going to add a push apart effector. So if my Voronoi is selected again, I can come in to do, where is it? Push apart. And that's going to push everything apart by 100 centimeters, which we don't want. Let's try 10 first. And then what we can do, we can actually just drag and drop our box field into here. Just change the blending layers just to make sure that it's affecting it. Yeah. Cool. So if I increase it, you'll be able to see easier what it's doing. But I just wanted to add a bit more of this kind of like push apart effect. So maybe let's leave that on there. Okay, cool. So I'm happy with that. I like how that looks. So if I go back to my original project, when it loads, there we go. So we've got this really nice kind of like curvy like noise displacement, just to kind of add to like a nice look. And all I used for that was a displacer deformer. So we can find that up with our deformers up here, grab our displacer. And what we have to do, we have to make it a child of the object that we want to add like the displacement on. So if I hold that, drop it on my sphere, at the moment it's not going to do anything, and that's because we haven't got a shader on there. So if I come under shading, under shader, we want a noise, and you can see now we've got this like noise displacement all across my sphere. So one thing I'm going to do, so under type, there's loads of different options here. Well, a couple of different options. So intensity centered basically means the displacement is happening in a positive and a negative kind of direction. But what I want is I want it just to be the positive direction. So I can do that by changing that to just intensity. And you can see how that's changed that kind of like the position of our displacement. Cool, right, so for mine, I had a height of -15 centimeters. And then if we come into our noise, we can change our settings, because at the moment it's all looking a bit too like jagged and jittery. So I found sparse convolution works quite nicely, especially if you increase the global scale to about 700%. So you're starting to get this sort of smoother displacement. What we can do, we can kind of stretch this out a bit more by decreasing our scale. And then what we can do, because we haven't got kind of any like 100% white or 100% black on here, we can actually increase our contrast. And if you take a look as I increase it, you'll see kind of what that does. So if I bring that right up, you can see how that's really creating some nice like curved lines. For me, that's a little bit too much. So I'm going to bring that down slightly, move it more. Like I said, this is personal preference, what you guys think looks best for whatever kind of outcome you're looking for. So I like this. I think that looks nice. And basically, this was the final bit. Let me, so if I turn off colorized fragments, you can see this is really what I ended up with. And yeah, a little additional thing. So what I didn't do in my first project, I didn't add any animation, but what you could do in the displacer under noise, you could do like an animation speed of 1. I'm also going to turn my segments down because the playback will be not very good on 120. So you can have, if you did want to add animation, that would be one way to do it. Or you could also come under your random effector, and in random mode, go to turbulence, turn that down a little bit. And so it adds like a kind of next level if you wanted to go for that. Yeah, and so that was literally this whole project. And then all I added was sort of like a cube. And if I come out here, that's like my environment. And then if I turn off all my lights, so lights can have quite like a dramatic impact on your scene. So all I've got is this cube with sort of like a flat color. And then on my Voronoi fracture, on my sphere, all it is a white material with like a GGX reflection sort of thing on it. And then I added a couple of rim lights, which is this one here. And it creates this like, I really like this minty color. And then this secondary one, which is this one here, which is sort of like a cooler blue. And then I've got my key light at the top and then my fill light at the back. And then I've also added a like an omni light, and you can choose like a visible light, volumetric. And when I switch that on, if you take a look in the middle, it really adds like a glow. And then a final little light, which is just sort of like, I found when I did a test render, around here was a little bit too dark. So I just flicked a another one of those on, and these were like the final renders that came out. So yeah, that was how I did that. So it's not just about kind of smashing things into segments. It was sort of another way of taking a look at the Voronoi fracture and how you can use different sources to create really kind of different looks to what you'd perhaps first like imagine, I guess.
It's not all about smashing things on the ground. Oh.
Well, it can be. It can be whatever you want. This is just something else you could do.
I think that looks, I really like that. And can you press play? Would it animate? Am I being?
So this one won't, because I haven't, I didn't do anything in like the displacer, so I could just do that, and then I'll see. Look, it doesn't like it because
Too much?
Yeah. Me and my too many segments. So that's obviously just the displacer.
Yeah, that's still interesting though. That's clever.
A nicer one might be just doing that.
We have a quick question. Just saying, what are the small tags doing next to the lights?
Oh, these ones?
Yeah.
Oh, okay, so these are like, you can do like a target tag. So if you right click, oh look, see, I'm not gonna remember where it is now.
Animation
it is
tag.
where is it? Animation, then you can go target, and then you can actually drag and drop. So like for me, I would drag and drop my sphere, and that means my light will point towards my sphere. Basically, I use this as a bit of like a cheap way of not having to rotate my lights myself. Sometimes I'll drop a null into the middle of my scene, and then I'll use that to target all my lights. Because then if I move my, let's say I then move my sphere and everything's targeted on my sphere, all my lights will then still remain looking at my sphere. So it's a bit of like a little tip there.
Thank you very much. And someone's asked, can you add thickness to it? I'm assuming you can just, have you on hull only on your, so.
Yes, so on this one, actually, they've spotted what I haven't done, because on this one, I have actually got the thickness. So yeah, back into this original one that we've just gone through, back in my Voronoi fracture, yep, you can just add a bit of thickness in there, and if I come closer, it'll make it a bit more obvious. So if I turn that up to more, you can do that. And then of course, if you find, so at the moment it's really jagged, that's because I took my sphere down to 32 segments again. If I increase that, you get that nicer smooth edge. And of course you can go higher if you want to, but you know, render times and playback and all that.
Absolutely. Right. Thank you very much for that, Elly. If there are not any more questions, then I will pass it over to Jonas. If you're ready, Jonas.
I'm ready.
Okay.
Cool.
Let's do that then.
So here we go. Can everyone see my screen?
We can.
Yep.
Perfect. So what I'm going to show is how to create this thing. Let me turn down the volume here. And this is also a fracturing setup created by Simon Fiedler, this animation here. And it shows how you can animate the patterns that you create using Voronoi fracturing. And that's exactly what I want to show you. So here we go. Right. Okay, what do we have? In the beginning, we just have one piece, and then it's being sliced up a little bit. It's multiple pieces now, and here it is very geometric. It's just like cubes, and then it blends into this typical Voronoi pattern, and this is what I want to show you. All right, so let's get started. So we are going to start with a cube, because the cube is always the starting point for something that is really awesome. And we make it flat. And then we are also going to create a matrix object. And the matrix object is pretty much the same as the cloner, but it doesn't create geometry. It just creates the positions and rotations and scales in 3D space, but nothing else. These positions and scales and rotations are represented by these cubes. If I hit render, we just got the initial cube here, so nothing too impressive. And for now, I will bring the count of the grid array distribution here in the matrix down to 1 by 1 by 1. And then what I will do is I set a keyframe here, and I go to, let's say, frame 40, and I bring this up to 7 by 1 by 7. And then I will also change this to be in endpoint mode. And let me also bring this up to, let's say, 120 by 120. And if I now scrub the timeline, you can see that we're starting with one matrix here in the middle, and then it's being animated up. Okay, so why do I do this, and what does this have to do with fracturing? Let me show. Okay, we want to fracture that cube. We want to break it apart, and we're going to use the Voronoi fracture object again. And I hold down Alt to make it a parent object of the cube. And now you see that we've got this random distribution again. And let me also offset the fragments just by 1 centimeter so we can see better what we are doing here. And now we're going to go to the Sources tab, delete the default point generator, and just throw in the matrix here. So what we see now is that it all starts with one piece, because it's just this one little point here in the middle. And then as the count of the matrices is going up, you can see that also the count of fragments is increasing. So here we go until it's at 7 by 7. So here we go. And now let me show you how you can blend this very straight pattern into the random pattern. Maybe again, one explanation that Matt already did before is because you can just see it really good here. Here are the matrices. The white squares are the matrices, and then you can see the cuts directly in the middle between each two of these matrices. So that's the basic concept here in action, and in a 2D plane you can see that very well. So I just wanted to show that again, in 3D space. And now let's see, how can we randomize this whole pattern? Well, here comes the advantage of using a matrix object as a source, because the matrix object is a MoGraph object itself. So what we can do on the matrix is we can use effectors. So let me create a random effector. Here we go, a random effector. And now you can see, all right, the matrices are at random positions. And this also means that now the pattern is completely randomized. Let me randomize the positions here just in X and Z space, not in Y. So we stay here in the plane. And then let me go to Effector, to the Effector tab. And if I bring down the strength here, the strength slider, you can see that at some point we are back at the completely straight lines. So what I can do here now is I just keyframe it. I set a keyframe here at frame 50 with 0% strength, and then I go up, or I go to frame 70, for example, and bring this up to a strength of 100%. And let me also just make the matrix invisible so we can see a little bit better what we're doing here. Press play, and maybe let me scrub through the timeline a little bit slower. So we are increasing the count, and then here, this is the point where everything gets randomized. And this is pretty awesome, because if we just make the whole scene a little bit longer, the other thing we can do in the random effector is we can set the random mode to something that is not static but animated. For example, noise mode is animated. Turbulence is also animated. These are the two animated ones. I'm going to go for noise. And now if I press play, you see this pattern here. Let me bring down the animation speed to, let's say, 20. And let's also check index here, because this will make all of the matrices move independently from each other. So you don't have this pattern anymore. Okay. And this is what we're coming up with then. So here we go. Isn't that beautiful? All right, that's
awesome. I really like that.
Yeah, that's basically it. And well, the other thing you can do still in the Voronoi fracture is you can add another random effector here and just modify the scale of those fragments. So we could go to the parameters tab and uncheck position, and instead we check scale, and let's say we want to randomize the Y scale here, so we can create something like that. Maybe you can see that better if I switch on screen space ambient occlusion. And yeah, let's also bring that up the moment we randomize the whole thing. So let me go to frame 50, yeah. Bring down the strength to 0, and then let's go to frame 70 and let's bring up the strength to 100. And now you can see that we're not just randomizing the pattern here, we are also randomizing the height of these fragments here. And that's the whole secret behind the piece that I showed you before.
And like you say, started amazing, awesome work, all just from a cube.
Yeah, so it's really easy to set up, and the effect is quite amazing. The other thing that you can do here, which is also really cool, is once you go back to the object tab, you can just invert the whole thing, and this way you don't see the fragments, but the gaps between the fragments, but also this thing has been animated because it's just the inverted thing. So
that's really,
there's a lot of stuff that you can do here, and yeah, a lot of ways to play with it. So that's quite exciting. And yeah, now my question is if there are any questions.
No, well, you seem to have made everybody speechless. In fact, all we've got is awesome, so cool, nice, and love it. So well done.
Perfect. So let's directly pass on to Elly before I get some questions.
Oh, that's cheating. Is there a way to smooth transition between increasing counts? And I think the answer is no, because you're simply making one cut and then two cuts. You're simply snapping the number of points there is between one and another. So there's no smooth transition that you can do with this.
Exactly. There's still a way how you could do that. Let me go back to the first frame and let me go to the matrix, because here we've got the animation. Let's just get rid of the animation track here. And this is something I learned from Lionel, which is an amazing quick tip. If you hold down Control and Shift and you click an animated dot here, you will delete the whole track. That's really cool, really neat. Okay, so what you could animate instead is the size here of the matrix. So let me set a keyframe here and go to the very first frame. And if we will just, let's say 1000 by, well, that's not enough. 1200 by 1200, something like that. You could animate it like this. So don't get distracted by the changing colors. That's because we've got more fragments here, and the colorization of fragments is random. So if I turn that off, you won't see that anymore. But this is how I would smooth it in.
Next question then. This is an interesting one. Would you put a bevel deformer in the stack, or could you use a Redshift like round corners node to get the effect from the finished presentation? So all of the fragments are sort of rounded on the edges, aren't they?
Yeah. Well, you can use the bevel. So let me just throw one in. But so here we go. Here's the bevel. Let me limit the whole thing. But sometimes it does weird things. Maybe let's apply it in a different way. Let's create a null.
Oh, I
and
see.
let's
Yeah, it's
place
not
the bevel here. So there is some bevel. And it's really nice at the moment. But the problem is, as soon as you've got really sharp edges here, this can lead into spikes. So in some cases, it works. In other cases, it doesn't. But for now, it seems to work. So there's also an alternative, which would be to throw all of this into a volume builder and create a volume instead, because then you can use the smoothness that you really want to have in the end, because with bevel you're always limited. Bevel is something that you would use on like machine parts and stuff like that, but if it's something animated and somehow becoming organic, I think bevel is not the right tool. Of course, you can use the bevel shader from Redshift. You can also create your own using the Cinema 4D internal material nodes. And yeah, then volumes. Those would be the three options you have. Brilliant. Or at least the three that
spring to mind.
I can think of at the moment.
Cool.
Yeah.
Thank you very much. Right, what we'll do, we will ping this back over to Elly now, who I believe has another example for us. And any other questions can be answered by Jonas in the question box.
Yeah.
Okay.
Are you ready, Elly?
I am.
All right. So then here you go.
Thank you very much. Can we see my screen?
We can.
Yes.
Cool. Cool. Right. So I thought I would go through how we can use a emitter as a source to create this kind of funky looking geometric animation, which is also using the two Voronoi fractures and kind of that using like the invert option within here. And so I did do like a little bit of a render here for you guys to see what it looks like. And then this was just sort of like a nicer looking one just for you guys to see what it looks like with some nice lights. So yeah, let me get rid of those. Cool, right, so let's go through how I did this. Right, so as Jonas said, everything great starts with a cube. So that's what we need, and we need it nice and thin. Right, so if I'm going to create my emitter first. So on the simulate, if you go to particles and then emitter, you'll get your little emitter box here. And I'm just going to make this a little bit smaller. And then what we can do, we can actually, in the horizontal angle, if we put 360 and then press play, what should happen is it will fire out the particles kind of like on a 360-degree angle. And that's what we need, because then if we get our Voronoi fracture, make our cube a child of it, back into sources, get rid of our default point generator, and then drag and drop our emitter in. If I press play, we'll see how our emitted particles are kind of triggering like the fracture pieces, sort of like that. But of course, that is way too quick at the moment, and that is because we need to go into the emitter. Under particle, we can kind of change these settings around. So let's do something like this. And so at the moment, our speed is way too high. And I think I did something like 20, a little bit of variation just so you get a nice kind of varied look. And if you press play, cool, yeah, so we're getting this nice sort of animated pattern with no keyframes or anything like that. Let me increase my frames to, what shall I do, 50. Cool, right, so that's kind of like the starting point. And back in our kind of Voronoi fracture object parameters, we can offset our fragments. Let's do something like, what should we do? 4, a bit too much. Let's go to 3. And then if we duplicate, so Command C, Command V, we can then, on our second Voronoi fracture, if we invert, we've now kind of like filled this gap with the exact same thing. If we reduce that down, maybe a bit more, so we can really see kind of the gaps. Now, if we go back and play, you get what I think is a really cool kind of geometric animation. And all that is with kind of like 2 of the Voronoi fractures doing the same thing, and then your emitted particles triggering those segments. What's nice about this is you can kind of drag and drop any object in here, and you could also kind of even go another step further by duplicating it again. And then let's do that, and then you can change the settings, like let's say on our cube. So I could increase that up to there, and then do the same on this one. Let's say that's 6. So you're starting to get really nice like patterns here. That are all following the same animation, so you don't have to worry about matching them up at all. And then, so I took this same idea and put it on like a torus. And so I've got my 3 Voronoi fractures, and then my torus are just different kind of like sizes. And so if we press play, I don't know how good the playback is, but it's just quite a nice way of kind of duplicating the same fracture. And then I rendered this out as well, and I just think it looks really cool and like really futuristic, even like not as an animation. I think is just like a model. So yeah, that's sort of a way you can use like the emitter and multiple Voronoi fractures together to create either a cool animation or a cool kind of model for anything. Yeah, so it's short and sweet from me, but just another little trick. Any questions on that?
It doesn't seem to be. We've had a question, can a still image video or a complete model be used as a source for fracturing? I'm not actually sure about the image side.
Oh, I shouldn't have thought so.
No, I don't think so.
Yes, that is possible.
Ooh.
A still image.
At least with a still image, because
right.
Where you can create a new point generator, there's also the possibility to add a shader source, and this should also eat images.
Yes.
Oh.
That's cool. So yes, in theory you can. What else have we got? Can you fracture but with circles like a bubble generator?
No.
No. Okay, fair enough. No.
No, that's not possible, because the Voronoi pattern, the Voronoi algorithm is what's lying behind all of this, and it doesn't create bubbles. So that's that's the thing. Well, you could clone onto the Voronoi points, and clone spheres onto these points to get bubbles, but there are better ways to do that, like circle packing algorithms, or even the push apart effector does a really good job when you want to create like a bubbly surface or setup.
Okay, cool, thank you. Right, so Jonas, is it time to hand back to you for the sort of the last part of this?
Yes.
Cool, I'll send it over. Also, to everyone watching, I will send these 2 files over, or 3 files, with the link to rewatch this. There you go, Jonas. Yeah, so I'll send the project files over.
Awesome.
So everyone gets them.
And I will do the same. So here we go. Can everybody see my screen?
Yep.
Yes, perfect.
Yeah.
So I was asked to show the animation I created before again. So here you can see the final animation again, and after that I will jump into the next setup. So the effort is not that big, but it's looking really nice. I mean, it's just like a metal surface and like a purple background. That's it. Good. So this is, or something like that, is what I want to show next. Well, the result we're gonna have is going to look completely different, but the setup is going to be the very same as in this example here. So yeah, let me just start. We are going to start with a platonic, and we're going to create a copy of that platonic and name this source. So it's the platonic source and the platonic, and they are identical. That's interesting for later. And then just to prepare my setup a little bit, I'm going to create a null and make both of these objects a child of the null, and then I select the platonic and create an instance of this one just to be more flexible later. And I will call this one object. So here we go. Then I can make the other ones invisible, and I've got my instance object here that links to the platonic. And the good thing about this is that I can replace this object easier later. Okay, so what I'm going to do is I'm going to fracture this object here. So we go to the Voronoi fracture, create it, and again I hold down Alt just to make it a parent immediately, and then we go to the Sources tab and again delete the default point generator, and here is the button, by the way, Add Shader Source, the one that we were just talking about. All right, so let's delete the point generator, and I'm going to use the platonic source here as the source. And as with all geometry objects that you input as a source, the vertices will be used as the source points. So what the result of this is that on every line here, there will be a cut directly in the middle. And this will create this very geometric pattern here, which is kind of awesome. And I'm going to go back to the object tab and just offset the fragments, let's say by 2. And I'm also going to invert the whole thing, which gives me something like that. Also awesome. And for now, I'm going to use hull only and a little bit of thickness, like so. So this is the object I want to create. And this is the first step to create the setup that I showed you before, or the visual that I showed you before. And the next thing I wanted to do back then was I wanted to create another line here, a parallel line on each of these, let's call them circles for now. All right, so how can we do this? Well, we can just create a copy and make the first one invisible. And then we can, in the object tab exactly, go to offset fragments, and instead of 2, we use something like 10. So we make this thicker, And now I would just cut everything here in the middle along these lines by using another Voronoi fracture object with the same source. So let me create another Voronoi fracture. And by default, of course, there's the point generator in here. Let's delete that. And let's also use the source object here, the platonic source. And now you can see that we created a cut along each of these. So we are fracturing the fractured object, which is a little bit weird, but it looks cool. So let me offset the fragments here now by 6, which is exactly the middle between 2 and 10. And then we've got this. All right, not too bad. So let's make the other one visible again. And so you can see that we've got 3 lines here. Well, every line turned into 3 lines. And we can just take this a step further and just copy this. Now we have to increase the offset fragments again. This time I'm going to use 18. And in this one, I'm going to use 14. So now we've got another line. And then I'm going to create another copy here. And in here, let's just type in +8 because all of these fields here are capable of calculating. That makes stuff easier. And here we go. So now we've got this as our object. And let me do some stuff that makes it easier to work with this. I'm going to select all of the Voronoi fracture objects, and I'm going to create a selection object for these. So I go to select, selection filter, create selection object, and this object here that we're going to rename Voronoi fracture has a link to all of the fracture objects in it. And if I double click this object here, I will select all of the Voronoi fracture objects, which is cool. And I'm going to do the same with the objects here. Select, selection filter, create selection object, and this is going to be my object selection. So that's just something to, make it easier to select stuff. You can find this a lot in character rigs, for example. And by the way, we are overrunning a little bit, so I hope you don't mind. Bear with us, please. But the stuff that I'm going to show next, I think it's worth it. So yeah, let's continue. We select all of these Voronoi fracture objects by double-clicking the selection object, and now I will untick colorized fragments, and let's create a few materials now. First, a white one, and I'm going to use it here and there, and then I'm going to create a copy, make this one a little bit darker. Sorry that I'm running through this a little faster, but it's just creating simple materials. And I'm also going to create one of the node material presets, gold, and apply it to this one. So now we are here. So far, so good. But what if we want to animate this, the pattern, for example? Or what if we just adjust the source here? For example, by increasing the segments. You can see that we now have this. So you can see that this is a completely procedural setup. And even if I animate this or displace the platonic source here, like for example with the displacer, let me do that. Well, I'm not going to use the displacer. I'm going to use the random effector because I want to show you something else. You can use any of the MoGraph effectors as a deformer simply by making it a child of the object you want to deform. And then the important thing is, with the random effector selected, you go to the deformer tab and switch the deformation on to points. And now you can see, okay, that's different. It got randomized, and yeah, let's just hit play. Nothing happens because we are in a static mode by default. So let's go to the effector tab, and the random mode is going to be noise. All right, so now you can see that this whole thing is even animating. Let me bring down the animation speed. And so this is also a pretty nice thing already. But I wanted to show you why I used instance objects here for the objects. All right, we can use any object in here. We cannot just use a platonic. So let me, for example, go to the content browser and search for one of the busts. Let's go with the generic head. And let's make it a little bit bigger, like so. And let's move it down. And maybe let's move the axis up, like so. And now let's use this instead of the platonic for the form giving shape. So let's double click the object here, the object selection object. And then let's link the generic head bust into this one. And let's also make the generic head bust a child of this null that is deactivated, and also delete the material. And here we go. So that's pretty awesome. All right, are there any questions? Because I'm at the end now. That's everything I wanted to show.
That's brilliant. Thank you, Jonas. That's a really interesting technique, especially with the animation. I like that a lot. Sorry, Simon. Yeah. Oh, I thought someone said something else. Sorry. Yeah, that's it. So unless anybody has any questions for us, then that's me, Elly, and Jonas done for a little bit. And thank you to Simon for having us once again. Don't forget, this webinar can be found on our YouTube channel, and you guys can just simply go and have a look at some of our previous webinars and everything that we've got uploaded so far. So unless there is anything else you want to add, Simon?
I just want to say thank you to you three for this month, because I just wanted to echo some of the great comments that we've had, not only today, but all through the last few weeks. It's so evident how much work has gone on behind the scenes to find things that are interesting and that bounce off each other's ideas. So it's not going unnoticed. So I just wanted to say, on behalf of all of us at Maxon, this is brilliant. Thank you. And it's just really repeating what people like. Vera has been very congratulatory all the way through. Thanks, Vera. And the same with Tom and Drake and Cheryl and Dominic and everyone who's put in the nice comments. It really is appreciated. Thank you. And the important thing is that that you're finding this useful. So that's great feedback for us. And we're always on the lookout for new topics, and we've got some good ideas that people have brought up over the last few weeks for the next sessions, the next time we jump into cinema. So please let us know. You'll get a little questionnaire form as the webinar closes, so please just type in there what you'd like us to cover, and the answer is we'll of course cover everything you suggest. It's just a matter of when, but it just is useful to find out what you need to work on and so on. But once again, everyone, thank you. Great stuff. And in answer to your question, Jonas, you're absolutely right. We never overrun. A trainer finishes exactly when they mean to.
Exactly.
Yes. So that's brilliant stuff. Thanks again. Please feel free to tune in next week. We've got another few weeks of exciting stuff covering effects on the timeline, and we might sneak in a little bit of looks inside cinema as part of that sharing workflow thing, especially if you're an editor and you need to share with your 3D artist, or vice versa. So we'll be happy to do that. But thanks again, all of you, for coming and joining us, carving out this time. I know it's not always easy when you're on deadline, but it's really great that you're able to join us. Fab.
Yeah.
So,
all right.
Thank you.
Take care, everybody. Thank you very much for joining us, and we'll see you next time.
Stay safe. Bye.
Bye.
Thank you. All right. Bye.